The reason why I'm harping on this idea of zero and its implication is because that this test statistic right here in and of itself is measuring how far is our point estimate, right, from our hypothesized difference, mu1 minus mu e minus mu o, which is zero. How far is our estimate from zero in units of standard error? That's huge. I like that question on a test. How far is the difference between these, this difference is from zero in units of standard error. And so the confidence interval gives you the same results as a hypothesis test when there's either a lot of evidence or we fail to reject the hypothesis, okay? It'll give you the same result. So here, when I created this test statistic and I implied that the p-value is extremely small, when I create a confidence interval, it should agree with that as well, indicating that zero is not plausible based on the data. So again, what are the implications of zero not being within the lower bound and upper bound? That tells us since zero is not within the confidence interval, it is not plausible that there is no difference between the population mean. This is consistent with our hypothesis test. We rejected the null hypothesis. The confidence interval and hypothesis test now always agree, but most of the time we'll always agree. If zero is outside the confidence interval, the test we will reject H naught at the corresponding significance level. Okay. In terms of experiment versus observational study, this was definitely an experiment in that I manipulated in some way, shape, or form the students regarding the are impacted the students in some way, shape, or form, indicating that based on what number they selected, that has an impact on how many letters they're able to memorize. Okay. Again, in terms of the comments, it'd be nice for you to tell me if this was easy, hard, medium, or easy, or from 1 to 5. You put it down below. But since this is video number 2, I'm not going to just stop here. I'm going to continue on to the paired t-test. I know in the last experiment, we legitimately, you participated in the treatment, but I don't have chocolate to give to you by way of YouTube. The technology doesn't exist yet. So this study, you can go ahead and read it, okay? But this study investigates which type of candy, milk chocolate or white chocolate, dissolves faster in a mouth. The sample is 63 students from a business class. Each student checked the day of the month they were born, and even birthdays started with white chocolate, odd birthdays started with white chocolate. They measured the time to dissolve both. The main focus is the difference in time to dissolve the chocolate. So in this situation, a couple weird things. This sentence here is strange, right? The students, in terms of the design of this set experiment, right, based on the birthday, right, that's going to have an impact on what they experience: milk chocolate first or white chocolate first. This is huge in terms of critical thinking, right? Because if everyone did white chocolate first, right, and then you did milk chocolate, we would have a confounding variable. Okay, if you're cool, say confounding, a confounding variable, okay? In that the order of the chocolate has an impact on the results. Whereas if we make it random, or at least, yeah, it's random in that what day of the month you were born, that determines what chocolate you have first. Then some people have white, some people have milk, and so we really don't necessarily know. That doesn't necessarily will have an impact on the outcome. The next big question is, why do I have each student, experience both types of chocolate? One could argue that, if it could be a weird accident where, some people who might have had iced coffee, iced mocha before class only have had white chocolate, right? Or someone who had coffee before class, hot coffee before class, only had milk chocolate. So what we're trying to do here in terms of this design, making sure that each student has both chocolate, is to reduce other variables that may actually have an impact on our analysis. Another way of saying this is that we're trying to reduce person-to-person variability by making sure that each person experiences both treatments. okay, which is different, okay, from the two independent population means t-test compared to the paired t-test. With the paired t-test, you experience both. That's a key difference. Key difference. One more time. Key difference. Key difference. Each person experiences each treatment, whereas two independent population means an observational unit only experiences one of the treatments. So SSVA, summary statistics, visualization, analysis. Here we have our distribution of data. This is a histogram, right? I would say this is semi-symmetrical. Well, semi-symmetrical, can't speak. This is unimodal, one mode. And I would say it's a little, there's some outliers here to the left, slightly skewed left, but overall, I'll say this is, close to being symmetric. Again, there are 63 students. The mean of the differences. Now, this is different. Okay, this is different from the first video in that instead of looking at each observation separately, since each person experiences both treatment, we're going to look at the difference for each person. So let's say, for example, you took 10 seconds to dissolve milk chocolate, and then you took 7 seconds to dissolve white chocolate. Your difference is going to be 2. And we're going to keep that white versus milk for each person. So we'll keep that same difference for each person. Okay? And so that average of the differences is negative 3.095. And the standard deviation of the differences is 13.493. Okay, it's an important thing to note. Again, this is a different sample. This analysis is from a different sample. Okay, here's my test statistic. Okay, it's quite small. Here's my degrees of freedom. Here's my corresponding p-value. Okay, and then you can see in terms of my confidence interval, here we go here. As you can see, 0 is plausible, right? And look here. The p-value is large. What should we do to our null hypothesis? Fail to reject, right? So those are the implications. So why don't you go ahead and answer, I think it's only 6 questions, 4 questions. Go ahead and at least try attempt those. All right, so if you were there on the first day of class, I mentioned, let's play the game, and the name of the game is pay attention, pay attention. So this element, we already know that the population is Cal Poly students and things in that regard. And sample with a Cal Poly student's convenient sample. That's fine. Let's go ahead and just jump right into the variable, or variables in this in this analysis. In the back of your mind, one could argue, the type of flavor that someone is, experiencing, and then the duration that it took for them to dissolve each flavor makes it 2 different variables. That's not correct. It's only one variable. Okay, the difference in time to dissolve milk and white chocolate in one's mouth is the variable of interest, okay, which is quantitative. Even though we did take 2 measurements, each person we're measuring that difference, we're analyzing that difference. It's important to note that. In terms of the research question, note that we are interested in the population of differences. The population mean of the differences. Whereas in 2 independent population means, it's the difference in population means, right? Whereas here, we're interested in just 1 mu d, the population mean of the differences in time to dissolve white and milk chocolate. And the technique that we're going to use is the paired t-test, the paired t-test. You're going to state the null and alternative hypotheses. Okay, the null hypothesis means that the population mean of the differences is equal to 0, meaning that there's no difference between the 2 groups. Whereas mu d not equal 0 indicates that there is a difference. There is a difference. So this is how you would write this. Okay, the population mean of the differences in dissolved time is 0, no difference. The population mean in dissolved time is not 0. It's not 0. Okay, so this is the test statistic x bar d minus 0 over sd over the square root of n. This should look familiar, as if it's a one population mean, because it's as if we're dealing with one population, right? Where our point estimate is going to be x bar d, and we're looking at how far x bar d is from 0 in units of standard error, and that's the standard error in the denominator. So using the sample statistics, okay, I did the math this time. We get negative 1.82. Okay, negative 1.82. If we were to actually find this p-value, it would be quite large. It would be, actually, I do remember calculating. I think it's 0.03. Okay, 0.07. We'll talk more about that in a little bit. So here, in order for us to calculate a 90% confidence interval, I'm giving you the critical value from the table, more specifically from R. Okay, you get the following results, and you would interpret it in the following manner. We are 90% confident that the population mean of the population mean difference in dissolved time, white minus milk, is between negative 5.93 and negative 0.26. Okay. Note that they're both negative. Okay. Note that they're both negative. With 0, in consequence, 0 is not included based on the data, indicating that there's no difference between white chocolate, and indicating that there is a difference in time to actually dissolve white chocolate versus milk chocolate. Okay, what direction is it? Which, if it's white minus milk, which chocolate technically takes longer? Ideally, you should have said milk chocolate takes longer, right? Because it's negative. All right. Before we answer point estimate, I want to make sure that we at least note something. Look at this. Our p-value is equal to 0.0734, and our interval, right, is really close to 0. And the point that I'm really after, at least what I'm trying to get you to think, is that yes, they do agree. This time they do agree, the hypothesis test in the confidence interval. However, it's slight, right? We have barely evidence against the null hypothesis. We only have some evidence against the null hypothesis. Look how close the p-value is to 0. Okay, look how close the interval is to 0, the confidence interval. So that's what makes it, we're actually close to the border of actually failing to reject the null hypothesis rather than rejecting it. We barely have evidence against the null hypothesis. Okay, so keep that back in your mind. So when it says parameter of interest, hopefully you all said, or at least are thinking of mu d. That is our parameter of interest. Mu d is our parameter. And then x bar d is our statistic, our point estimate. So you can at least have that information. Okay? All right, thank you so much. Have a good day.